Good day everyone and welcome to another video. In this lesson, we will be talking about energy, the energy consumption of the entire world, how do we benefit from it, and what are the impacts of energy production to us and to our environment. So let's begin. To convey my point in this lesson, I'll be presenting you with many graphs which we will interpret in order for us to have a clear picture regarding our energy production and consumption. For our first graph here, we have the global energy use, both historical and present. So you see that this graph starts from 1800 down to 2019. And this graph is broken down into the different sources of energy that we have, both renewable and non-renewable. The first thing that strikes us here is how rapid is the growth in our global energy consumption. This rapid growth is primarily driven by non-renewable sources of energy such as coal, oil, and natural gas. And you can also see that those three non-renewable sources have the biggest share in our global energy consumption, while the remaining sources, such as nuclear, hydropower, wind, solar, and other renewables, only make up a small portion of our global energy consumption. Now, if we take a look at the growth of energy consumption for different regions of the world, you can see here that Asia Pacific is still largely growing in terms of consumption. This fast growth in energy consumption reflects a fast growth in population as well as a fast-paced development. If you compare the growth trend of Asia Pacific to North America and Europe, it would seem that North American and European consumption has reached some sort of a plateau because they are already developed countries, so they have already reached their peak. The stark differences in energy consumption also reflects the differences in population. Asia Pacific houses a large percentage of the population of the world, and if you compare that with other regions such as Africa, Middle East, and South and Central America, it would now be clear why Asia Pacific has a very fast growth in energy consumption. Now, let's take a look at the case of the Philippines. We have this graph on your right, the per capita energy consumption through the years. So in 1965, we started at about 1,800 kilowatt hours per capita per year. And as of last year, our per capita consumption ballooned to about 5,200 kilowatt hours per year. What this graph represents, even though it has its ups and downs, is that the total per capita energy consumption of the Philippines has steadily increased, mainly due to infrastructure development and the rapidly urbanizing population here in the Philippines. But if you compare the case of the Philippines to those of other countries here on the map to your left, the Philippines is actually just at the middle of the spectrum in terms of consumption. Those at the higher end of the consumption are typically your developed countries, USA, Canada, Middle Eastern countries, Australia, China, European countries, etc. And those at the lower end of the spectrum are normally the third world countries or the developing countries. It could also be the case that the countries at the lower end of the spectrum are mainly depending on traditional sources of energy such as biomass, which are used for their cooking and for daily activities. So moving forward, it's not just enough for us to know how much energy are we using. It's much more important for us to determine what are the sources of our energy, because the sources of our energy would dictate if we are on the path towards sustainable development, which we will cover later. So this is the energy generation mix for the Philippines as of 2016, based from the data of the Department of Energy. What you immediately see from this pie chart is that majority of our energy is still coming from oil and coal, which are non-renewable sources of energy. But the good news is, a big chunk of our energy generation also comes from renewable sources of energy such as geothermal, biomass energy, and hydroelectric energy. And looking at this chart, solar power and wind power represents only a very small portion of our total generation. That could mean that we still have some space for the expansion of our solar photovoltaic technologies. Regarding our sources of energy, as shown in this figure on your lower left, we have the energy self-sufficiency chart of the Philippines from 2008 to 2016. Our energy self-sufficiency hovers between 50 to 62%, meaning that more than half of our energy needs is sourced from our country, and the other half, roughly, is being imported. Majority of our import includes oil and coal because the Philippines do not have very large reservoirs of oil and coal. And the coal that we have here is of a lower grade compared to other coals. That's why we import majority of our oil and coal needs. This is another view that we can take regarding our different energy sources and how much we are extracting throughout the years. You can see that the general trajectory for oil, the three biggest non-renewable sources of energy that we are using, are still steadily increasing up to this day. That is in stark comparison with the renewable sources of energy such as hydropower, wind, solar, and other renewables, which are all still lagging behind the growth of the non-renewable sources of energy. So what does this mean for us? The continuous growth in usage of oil, coal, and gas means that we are still being reliant on cheap energy, which is mainly being used to fuel our developments. As we have discussed in one of our previous lessons, the continuous increase in urbanization results to us needing more and more resources. And since oil, coal, and gas are relatively easy to source and are relatively cheap, then we are continuing to use those even though we have a lot of potential from renewable energy sources. So now that we have discussed where our energy comes from, let's now discuss where our energy is being consumed or where is our energy being allocated. You see here that majority of our energy is being delegated towards transportation. This transportation mainly pertains to the fuel that we are using in cars, in airplanes, and in ships. Another big user of our energy is the residential sector, meaning houses. Since we have a large population in the Philippines, we do expect that the energy being consumed in the households would play a major role in the entire energy consumption of these sectors. And the other sectors that are given a share in our energy consumption are industrial and commercial establishments, as well as agriculture, fishery, and forestry. Now let's talk about how do we generate electricity coming from non-renewable sources of energy. Now, since majority of our electricity for residential and commercial use are still coming from non-renewable sources of energy, and since it will not be sustainable if we immediately order the closure of our coal-fired power plants, it would be important for you to know what is the process behind the extraction of the stored energy of fossil fuels. So we start from the coal supply because the combustion of smaller pieces of your solid fuel is faster and more efficient. So after pulverization, the powdered coal would be then sent to the boiler wherein it is combusted, and the heat generated during combustion is used to boil water, and the boiling of the water turns it into high pressure steam, wherein the high pressure steam goes through the steam turbine generator to generate electricity, and then the low pressure steam from the outlet of the turbine would then go through a condenser so that it can be recycled back to the boiler. After combustion of the coal, the gaseous combustion products, known as the stack gas, are then purified and released. And then from the steam turbine generator, the electricity being generated is first stored on site before it can be transmitted to our electric grids. Now you might be asking, why is it relevant for us to study these types of electricity generation methods? Because we have mentioned earlier that the burning of fossil fuels is bad for the environment. The answer is, the generation of electricity from burning or from combustion still dominates the global production because it is relatively cheap and readily available. And it's this cheap and reliable source of energy that is fueling our development. So even though combustion has its negative impacts to the environment, we still cannot abruptly stop all combustion power plants because that would severely hamper our development, and that is not sustainable. Okay? Our best course of action would be to slowly phase out these types of generation in favor for processes that use renewable sources of energy. So as I have mentioned, there are several impacts of electricity generation coming from the combustion of fossil fuels. One of the biggest impacts of these types of electricity generation is air pollution. Air pollution in terms of the acid gases being produced during combustion, as well as particulate matter and other toxic gases found in this stack gas. Also, we have these other impacts of combustion aside from air pollution, we have the greenhouse effect and climate change. This is one of the biggest impacts of the burning of fossil fuels because it produces a large amount of carbon dioxide that is a potent greenhouse gas that causes greenhouse effects and in turn causes climate change. Another impact is environmental damage arising from the mining of the fossil fuels that are needed for the generation of electricity. And finally, we have accidents from the supply chain, which includes mining of the resources, generation of electricity, up to the distribution of electricity. Now, I have mentioned before that our rapid development and our rapid use of fossil fuels as sources of energy is having an impact on our atmosphere, particularly to the addition of the greenhouse gas CO2 to our atmosphere, leading to global warming. So, shown here are two different graphs. The graph on your left was the previously presented global energy consumption, and the graph on your right is the total annual carbon dioxide emissions of the world. Now you see that they are of similar shapes and they both started to rise at the same times. That means that there is a correlation between our use of fossil fuels and the proliferation of carbon dioxide in our atmosphere. Now this carbon dioxide in the atmosphere leads to greenhouse effect, which then leads to global warming, and we will be discussing that in a separate lesson. But these evidence now show that our continuous use of non-renewable sources of energy is one of the main contributors to the continuous rise of CO2 in our atmosphere. And with that, we strongly believe that our future is renewable. The increase in proportion of renewable energy share in the total final energy consumption is one of the targets of the Sustainable Development Goal number 7, affordable and clean energy. So therefore, it is of our best interest to continuously increase the share of renewable energy in our annual consumption. Shown here on the graph is the share of the final energy consumption from renewable sources of different countries and regions. If you take a look at the world average, it seems to be staying steady at just below 20%. Now, the main contributors to this steady rate of utilization of renewable energy for the entire world is attributed to the balancing between the increase in usage of coal, oil, and gas versus the increasing spending and therefore increased use of renewable energy sources. Now, if we compare the case of the Philippines to that of the world average, we are still above world average, but then you can see that the trend is slowly decreasing. That's because up to this day, we are still inaugurating new coal-fired power plants to boost our energy generation. And couple that with the slow growth of renewable energy in our country, that means that the percent share of renewable energy in our country would be expected to continuously decrease as we add more and more coal-fired power plants. If we contrast that to the case of Germany, Germany is still below the world average, but its share of renewable energy is continuously increasing. That's because they are spending more on renewable energy technologies, and their continuous investment on renewables means that they are on track to surpass the world average someday. Now, how about Sub-Saharan Africa, Bhutan, and Nepal? It seems from this graph that majority of their energy consumption is coming from renewable energy. Well, technically that's correct, but majority of their renewable energy is coming from the combustion of biomass, such as wood, charcoal, and other biomass. So this big share of renewable energy for those countries is not a result for big spending of renewable energy infrastructure. It just so happens that majority of the population are still using biomass for their day-to-day lives, such as for cooking and for heating. Now, if we take a look at the world map, that gives us an idea of what countries are utilizing renewable energy sources. We see that majority of the Central and South African nations are all reliant on renewable energy, and that is mostly biomass. Canada, Brazil, and most of South America, as well as some of the European countries, are now heavily reliant on renewable sources. So in the future, we are hoping that this entire map would turn into dark green. That means that we have already achieved one of the targets of Sustainable Development Goal number 7. Next, we take a look at how much is the world investing for the development of renewable energy technology. We see here several things. First is that the investment is steadily increasing as the years go by, and we are expecting this to increase furthermore as we are under pressure to fulfill Sustainable Development Goal number 7. Second, we also see that solar energy and wind energy take up majority of the investments for renewable energy. The reasons for that is because solar and wind energy are both proven to be economical, they are easily scalable, and they are easily deployable in many areas around the world. That's why they are some of the most heavily researched areas on renewable energy. Other technologies that we are also investing are biomass, biofuels, small hydropower, geothermal energy, and marine energy. So we are expecting in the future that some of the other renewable energy technologies will also be heavily funded for development. Now, let's get to the topic of how safe are our energy sources. We have already discussed earlier that our non-renewable sources such as coal, oil, and gas are very dangerous to our environments, especially to our atmosphere. But how dangerous are those technologies to human health? To give a fair comparison, the death rates coming from different sources are normalized according to the amount of energy generation. So we have here entries for brown coal, which is coal which has a lower percentage of carbon, coal, oil, biomass, natural gas, and nuclear energy. And by far, the energy source that causes the least amount of deaths relative to the amount of energy being produced is nuclear energy. That is contrary to the popular public perception that nuclear energy is very dangerous. In fact, it's not. The generation of energy from coal, oil, and gas actually take up the majority of deaths related to energy generation. Now, these deaths are due to accidents and air pollution. So, the air pollution coming from our energy generation is killing a lot of people. And if we further compare the different sources of energy in terms of the death rate due to accidents and air pollution, as well as greenhouse gas emissions, you can see that coal and oil are both topping the list as both dangerous to the environment and dangerous to human health. And one of the safest sources of energy that we have is biomass, natural gas, hydropower, and all of the other renewable sources of energy. They produce the least amount of deaths over their entire life cycle, but they also produce the least amount of greenhouse gas emissions, which is ultimately good for our environment. So if we really are considering sustainable development, considering both protecting human health and protecting environmental health, you can now see that indeed, renewable energy is our future. For further readings, I want you to read about the improvement of efficiencies of solar photovoltaic cells over the years. You would be surprised at how far we've come in terms of the efficiencies of solar panels. Also, I want you to read about novel and emerging renewable energy sources such as microbial fuel cells, hydrogen energy, tidal energy, and reverse solar panels. These are just some of the emerging technologies that are still at the research stage, and we are still studying if they can be applied to a larger scale. For your second worksheet, first, I want you to construct a table that enumerates the positive and negative impacts of all energy sources that you can think of, both renewable and non-renewable. So we want to compare the positive and negative impacts for renewable and non-renewable sources of energy. Energy sources that should be in your list are coal, oil, natural gas, solar photovoltaic, solar heating, wind, hydroelectric, geothermal, biomass, and nuclear. You are encouraged to add more sources to this list and be thorough in your research for impacts. I do not want to see generalizations of impacts such as harmful to human health, etc., etc. They have to be specific. For number 2, explore the concept of waste to energy. This process extracts usable energy from some of our common wastes, including sewerage, garbage, agricultural waste, food waste, etc. I want you to name 3 waste to energy technologies that you think would have a big potential in the Philippines. Explain the concept behind the technology, where did it originate, what is the process of energy extraction, how efficient is the conversion, and most importantly, how can the technology help in attaining our goal of sustainable development? Okay? So those two items are for your second worksheet. That's the end of this lesson. I hope you have learned something. Please pursue the further readings for you to have a better understanding of the role of energy in sustainable development. And as always, keep safe.